All right, practice problem 1. We're going to read and annotate. We've got Jaden. He's using button core to design buttons. That's not important. All right, total cost can be found using the equation C equals 0.5B plus 8, where C is the total cost. I don't know why mine's missing so much. C is the total cost in dollars, and B is the number of buttons ordered by Jaden. So we need to create a table to show the cost of 10, 20, 30, 40 buttons. So the first thing you're going to do is you're going to set up the big table, okay? You've got to have your middle section to show all your work. We've got X. We're not going to call it X. Our X here is the number of buttons. They're calling it B. They don't always call it X and Y, but it's the input. So this is the number of buttons. So in your table, I'm looking for you to have number of buttons. I don't care if you have B or not. Then the end, that's our Y, that's our output. That's going to be the total cost. They're calling it C, okay? Don't get confused by that. Now in the middle, we don't put the whole equation. We put everything after the equal sign. So we're going to put 0.5B plus 8. Okay, the middle is where we show our work. And they want 10, 20, 30, and 40 buttons. So they chose our X's for us, right? Remember, that's what we're in control of. So we're going to do 10, 20, 30, and 40 buttons. Now, how much is that going to cost? Plug in these X values, plug in the buttons into the expression. So I'm going to take 1/2 of my first B value, my first button, which is 10, and then add 8. So half of 10 is 5. 5 plus 8 is 13. I'm going to keep doing that. I'm going to take half of my buttons, which is 20, and add 8. Half of 20 is 10. 10 plus 8 would be $18. Keep going. Half of my buttons, which is 30. Half of 30 is 15. If I add 8, that's $23. For 40 buttons, I take 0.5, plug in my buttons, which is 40, add 8. Half of 40 is 20. 20 plus 8 is $28. So they said create a table to show the cost. We did that, so we're done with this part. Next part, they want to know, how is the table different from the algebraic representation? Meaning, what does the table show you versus what the equation will show you? So, by looking at our table, right? I'm not going to put the whole thing, but we had 10, 13, 20, 18, etc., right? The table shows you the cost for a very specific number of buttons, only 10, 20, 30, and 40. It doesn't tell you the cost of 5 buttons. It doesn't tell you the cost of 25 buttons. The table only shows you the cost for 10, 20, 30, or 40 buttons. So we're going to start there. The table shows the cost for specific amounts of buttons. Then I'm going to tell you what I mean by that. For example, this is how you get a full, complete answer. For example, comma, 10 buttons is $13. Okay? That's what a table shows you. The algebraic expression, which is this, the equation, but we're going to not call it the equation because we want to know that those are the same thing. So we're going to write the algebraic representation, fancy way of saying the equation, The algebraic representation gives a formula that will give you the cost for any amount of buttons. Any amount of buttons. What does that mean? I can plug in a 3 into that formula if I wanted to know how much do I have to pay for 3 buttons, right? It would be $9.50. Because I'm going to take half of 3, I'm going to add 8. How much for 100 buttons? $58, right? I can't see that in that brief table, but the equation, the algebraic representation, allows me to plug in any number I want to find the total cost of buttons. So that's the difference. This is kind of a lot to write, but make sure you have that. You need to understand that. That's going to be the same for any table and any algebraic representation. If you know this formula, you can figure out any x value you want. But if you've got a table, you're limited to a very short number of x values.